This video will give the introduction to the Augmented Matrices lesson, as well as show the examples for the 2x2 systems. An augmented matrix is a separate approach other than Cramer's rule for how to solve a system of equations using matrices. So here we have a system of two equations and two unknowns, and it allows us to answer the question, what is an augmented matrix? So what we would do is we would rewrite this matrix as an augmented, or this system as an augmented matrix. We would include only the coefficients of the different terms, and then attached to the coefficient matrix, which is what this left side is called, is the coefficient matrix, we are going to augment it, attach the answer column. This type of matrix can be solved using what is called row modification to find the answers to the system of equations using a certain set of rules. So, the legal row operations, there are 3 of them. You are allowed to multiply an entire row by any number you would like to, any scalar. You are allowed to swap any 2 rows, because remember, the rows represent equations. You're allowed to switch the equations around if you want to, just like you're allowed to multiply both sides by whatever value you want. And then the third thing you're allowed to do is you're always allowed to add any 2 rows together. Now that is a little bit less obvious, but if you think about it, when you've used elimination in the past to solve a system of equations, what are you doing? You're adding the equations together. So there's no reason why you can't add 2 rows together. Now the 4th rule technically is just a combination of the other 3. You are allowed to do any combination of the first 3 rules. In other words, you could multiply a row by 3 and then add it to another row. That would be a combination of rules 1 and 2. Now you might wonder, okay, but what's the point? Well, the goal of row modification is to take that original augmented matrix and turn it into the identity matrix augmented with a pair of numbers. If we can get the identity matrix to be where the coefficient matrix starts, then these will be the answer to the system, xy. So that's the goal. We want to modify the original augmented matrix into an augmented matrix where you have the identity matrix attached to an answer column. So we're going to jump in. It's really the best way to do this. Here is a system of equations that we're going to solve using an augmented matrix. This is the same one we had earlier. So we're going to pull those numbers off, creating an augmented matrix. And we're going to use row modification to reach our goal, which is the identity matrix augmented with x and y. Now, ladies and gentlemen, this is a very, very set process. You need to start by getting that 1. So to get that 1, we don't already have a 1 in the first column. So what we're going to do is we are going to multiply row 1 by 1/5. In other words, we're going to divide the first row by 5. Okay, remember that division is really just multiplication by a fraction, so you're allowed to divide by a number as well. When we do that, the new first row would be 1, 2/5, 8/5. And we didn't do anything to the second row, so that is still 2, -3, 7. That gets us our 1 in the upper left. Now, after we have the 1 in the first column, we need to get everything else in that row to be a 0, or in that column to be a 0. So next we're going to move down and we're going to get the rest of that row handled. We're going to turn everything else into a 0. And the way we're going to do that is we're going to use a combo move. We are going to multiply a copy of row 1 by -2, and then we're going to add it to row 2. So the way I like to show this is I will show the multiplied copy above row 1. So if I'm going to multiply row 1 by -2, that would give me -2, -4/5, and -16/5. That's these numbers multiplied by -2. And then I'm going to add those numbers together. So I'm going to go negative 2 plus 2, negative 4 fifths times, or plus negative 3, negative 16 fifths plus 7. That will give me, and I'm actually going to be down here, so I'm going to fix that here in just a second. The first row is still 1, 2 fifths, and 8 fifths. And the new second row is 0, negative 19 fifths. I know, that's tough. Okay, this is negative 15 fifths. Get a common denominator. Add negative 4. Okay. And then 19 fifths. If you're unsure about it, use your calculator. That is what it's there for. So then, and I'm going to fix this real quick so you guys can follow along with me here. Again, notice I'm writing what I'm doing each step. That is a requirement. That's what I expect to see in terms of work. So next, we need a 1 in the second row. So then we're going to move here and get that 0, that 1 next. So to do that, we're going to multiply row 2 by the reciprocal of this number, which would be negative 5 over 19. That would change that system. The first row is still the same, pardon me, and the second row is now 0, 1, negative 1. So the fractions were kind of short-lived. Now we need to do one more combo move in order to get a 0 where this 2 fifths is located. So after we get that, then we move up and we finish off that row. Okay, so now we're going to move up and get the rest of the zeros. So we kind of move in a U pattern for a 2 by 2. We start here, get the 1, get the 0, get the 1, get the 0. Okay? So to do that, we're going to multiply a copy of row 2 by negative 2 fifths, and we're going to add it to row 1. So that would be 0, negative 2 fifths, and positive 2 fifths. And then we're going to add those numbers to the numbers in the first row, which will result in a system 1, 0, 8 fifths plus 2 fifths is 10 fifths, which is 2, 0, 1, negative 1. So at this point, we're done. X is 2, Y is negative 1, and our answer, written as an ordered pair, is 2, negative 1. Now, I realize that this is not the shortest method for solving a system of 2 equations and 2 unknowns. However, an augmented matrix is by far the shortest way to solve a larger system. So you are not allowed to solve it any other way. You need to solve it the way the directions say to solve it, which is using an augmented matrix. Let's do another example. So here's another one. We're going to start off with an augmented matrix, 2, 1, 5, 2, negative 4, negative 1. Now, this one has a shortcut. Remember what our goal is. Our goal is to get the identity matrix augmented with the answers. We still need to start with this 1. We need this 1 first, right? And then we're going to move down, go over and get that 1, and then back up. That's the process, okay? So, if you notice, in row 1, we already have a 1. So there's no reason to divide by 2 and create fractions. You can. It doesn't make any difference, but you don't need to. We can simply swap row 1 and row 2, which would simply switch the rows and give us a 1 where we need it in the first row. Then we'll carry out a combo move. We will multiply row 1, or a copy of row 1, by negative 2, and then add it to row 2. So that'd be -2, -4, +2. And we would add those values together, which would give us 1, 2, -1 in the first row, 0, 1, and -2 in the second row. Hey, look, we got incredibly lucky. Our next step would be to get a 1 right here, but that's already accomplished. So now we just need to do another combo move. We need to multiply row 2 by -2 and add it to row 1. So that would be 0, -2, +4, and then we would add those values together, which would give us our final answer for the augmented matrix part. Our new first row would be 1, 0, 3, and our second row is still 0, 1, -2. So again, that is done. Our answer is 3, -2. Let's do another one. Haha. Okay, here is our next system. So again, we're going to start off with an augmented matrix, 10, -5, -10, 4, 1, 20. First step is to get a 1 where the 10 is currently located. So we're going to multiply row 1 by 1/10. It's just like dividing the first row by 10. So that'd be 1, -1/2, -1, and the second row would remain the same. Then we're going to carry out a combo move. So we're going to do row 1 times -4. We're going to multiply row 1 by -4. And add to row 2. Which would be -4, +2, and +4. And then we would add those values to the second row. I probably don't want to use black highlighter. That's a pretty poor choice. So add those numbers. And that generates our next step, which is 1, -1/2, -1, 0, 3, 24. So then we need to get a 1 where the 3 is located. So we are going to multiply row 2 by 1/3. Let me clean that up a little bit. This little thing here is bothering me. It's not very clear in my opinion. Okay, multiply row 2 by 1/3, which is the same as dividing row 2 by 3. So our first row is going to stay the same. Our second row is now 0, 1, 8. Then we need to carry out one more combo move. So we're going to multiply a copy of row 2 by 1/2 and add it to row 1. So that would be 0, 1/2, and 4. And we would be adding those numbers to the first row to create the new first row. So our final augmented matrix step would be 1, 0, 3, and the second row is unchanged. Meaning x is 3, y is 8, And our answer is 3/8. Okay, that does it for 2 by 2. See the next video for an example of a 3 by 3.